What's up, everybody, and welcome back to another live stream from the Scalar Learning channel. And today we are back at it with this Khan Academy series, going through all of the concepts for the math portion of the digital SAT, this brand new digital SAT that's coming out in March, not too long from now. So we're very excited here at the Scalar Learning channel, and we're trying to get you guys ready as well. So if you are following along with this series, you should be checking in on the daily. We got new videos, sometimes multiple videos coming out every day, and I'm going through practice problems of each section and explaining and teaching how to handle each of these types of problems. We're starting in the foundations level, and I'm seeing these questions for the first time in real time, so you're going to see me problem solve and think on the fly. And without further ado, let's do it. A tank holding 600 liters of milk is leaking. Each week it loses 60 liters of milk. Let M be the number of liters of milk remaining in the tank after leaking for T weeks. Which of the following best explains the relationship between T and M? So before we even go into this, right, what we're doing in linear and exponential, usually comparing or deciding is this modeling linear or exponential growth. The key is with linear growth, the rate of change is constant. So whether you're losing or gaining, whether you're growing or declining, it's by the same amount every same period of time. So if it's every day, like in this case, maybe it would be you're losing 60 liters of milk. In this case, it's per week, right? But you're losing constantly 60 per week. So this looks like linear. Anyways, so now let's see the answer choices. The relationship is, it's linear. So it is linear. So it's not exponential. So it's not B or C. Yeah, it's this one. Every time T goes up by 1, the time unit is going up by the same amount. This is decreasing by 60. Let's see A, because M always decreases. No, it's not about always decreasing because that could still be exponential decay. All right, there we go. Number 2. Diyama planted a palm tree in the backyard of his house several years ago. Initially, it was 200 centimeters high, and its height increased by 30 each year. Okay, again, I'm seeing each year it's increasing by 30. Linear. I already know, and it's linear increase. Okay. Which of the following best explains the relationship, right? If just to contrast it, if it said it increased by 30% every year, now we're talking about exponential, because 30%, even though that value stays consistent, the amount it changes by changes as it increases. So for example, you start at 100, 30% is 30. Now you're at 130, 30% is now 39. You see? So the rate of change is actually growing. So that's the idea. But anyways, it's linear because H increases by 30. Yep, same idea, right? By that increases by 1. Yeah, it doesn't increase by 200. 200 is the starting value, aka y-intercept. All right, here we go. Next, number 3. So long questions. Which of the following savings account plans would yield exponential growth? Again, so now we're talking about exponential. That last example that I gave with percentages, that's what we're looking for. Percent of what is in there now. So it's growing by 10% every year. Not something like, and let's see if they have an example of this, 10% of the initial amount, of the initial deposit. Because then if you deposit $100 initially, right, it would be 10% the first year, now you're at 110. But then you said, 10% of the initial amount. So next year I'm not gaining 11 or something more, I'm just getting $10 again, $10, $10, $10. That's linear. So 2%, so you see how they put this here? Of the initial value, wrong. 1%, 1.5% of the current value. This is what we want. Percent of the current value. So every time that current value augments, now that percentage is yielding a larger percentage, a larger return. So that's why it's changing its dynamic. $100 no, $500 signing bonus, and a 5%. And again, initial, wrong. We wanted exponential, right? Yeah, exponential. Boom, done. Last one. Here we go. Okay. We've got Fang and Meng have a large rose garden when the roses first bloomed. They initially picked 4 fresh roses each day thereafter. As more roses bloomed, they quadrupled the number of roses they picked. Okay, wait, hold on. They each initially picked 4. Each day thereafter, they quadrupled the number of roses they picked. So then it's 16, then it's 64. Yeah, I mean, as long as I'm understanding that right, each day thereafter, they quadrupled the number of roses they picked. So that's what it sounds like. It doesn't sound like it's like 16, 16, 16, right? It sounds like it went from 4, that quadrupled to 16, then that quadrupled to 64. So that's definitely exponential again. As the increase is dynamic, it's changing. It's going up by 12, then it's going up by 48, etc. Because okay, so let's read this. Values of R always increase. No, that's not a good explanation. We're saying it's not linear. Let's go down to another exponential. Increase it by a factor of 4. Yeah, that's it. A factor, when it's increasing by a factor of 2, of 3, of 1.5, there's your exponential. Also similar to a geometric sequence, if you guys remember that. Okay, that is it for today. If you guys did like this video, please click that like button. If you want to see more from the Scalar Learning channel, make sure to click subscribe. And if you're looking for the best resource to study for the digital SAT, check out the SAT Crash Course. Description or link is in the description below. 20% off discount if you use the code SCALAR, all caps. All right, guys, that's it. We're on the mission. We're on the path to this March digital SAT debut. I wish you all the best of luck. Thank you guys so much for joining, and I'll see you in the next